platform. Welcome to this platform. So we continue with organic chemistry. In this one, our main focus will be on alkenes. The first part we did introduction to organic chemistry, looking at the terms under the study of organic chemistry. Then we ended by looking at alkenes, and we covered part of alkenes. But in this one, we start alkenes from the start. So which means this is lesson 2. If you've not watched lesson 1, very important that you go through before this one. Otherwise, everything that we are going to discuss will be connected to the first part. Okay, we can start. So the first question here is, what are alkenes? Remember, alkenes, we said they are saturated hydrocarbons. And this is because between carbon, or the bond between carbon and carbon is a single bond. And that is the reason why they are saturated, which means they cannot allow more atoms to attach. They are stable, the bonds are stable. But coming to this, let me not say it's the opposite, but we are going to say alkenes are unsaturated. So alkenes are unsaturated hydrocarbons. And I guess you have an idea what it means, unsaturated hydrocarbon. So the unsaturated hydrocarbon, this means that they have, or this is because, let me say because of carbon to carbon double bond, because they have carbon to carbon double bond. Now, how does that make them unsaturated? This double bond that you are seeing here can break and of course form single bonds where other atoms can attach. In other words, here the bonds are not stable. So they can break, or the double bond can break, and more room for attachment of other atoms or other atoms here can be created. This makes them unsaturated. Okay, now that double bond is referred to as the functional group. Okay, that double bond is referred to as the functional group. Now, where we are coming from, among the terms that we looked at, we said the functional group is as a group on the compound that determines its chemical reaction. So how they react, okay? So this makes the alkenes reactive, okay? Now, the other thing that we need to look at is the general molecular formula. What is the general molecular formula of alkenes? And when we say general molecular formula, we are looking at where all these alkenes are made from. So the general molecular formula here of all the families under alkenes is CnH2n, where we said in the introduction that N refers to the number of carbons. So N refers to the number of carbons. So very important to know the general molecular formula. Okay, now let us proceed and look at the first five alkenes. Okay, the first 5 alkenes. Now, to look at the first 5 alkenes, we are going to refer to the general molecular formula as well as other concept that we learn that is under nomenclature in the first one. We said in order to name these compounds successively, we take into account the prefix and also the suffix. The suffix, we are just looking at what we put at the end of a name, and the prefix at the beginning of a name. Now, very important to remember that at the beginning of the name or the start of the name of these, that is the prefix, comes from the number of carbon. We said if it has 1 carbon, it's called a meth, that is for the prefix. If it has 2, it is called the eth. If it has 3, it's called the prop. 4, it is called the but. And 5 is called the pent. Going down, 6 is called the hex. 7 is called the hept. 8 is called the oct. 9 is called the non. And 10 is called dec. So this is what you put at the beginning of the name. In the case, it has 1 carbon, meth, 2 carbon, eth. Now, let us look at the suffix. So for the suffix, we said it comes from the family. So in this case, we are dealing with alkenes. And alkenes family, the end part of the name should end with E-N-E. And therefore, to make the name of the alkene, we put E-N-E at the end. Now, it's very important to note that there's no alkene with 1 carbon. Okay, there's no alkene with 1 carbon. So it all starts from carbon 2. Therefore, the first one in the series is ethene. We just add eth for the prefix, ene for the suffix. The second one is propene. The third one is butene. The fourth one is pentene. And going down. Now, what is important here, the question might come, name the third compound in the family of alkenes. Not specifically that way, but sometimes maybe you are given the questions. That leads you to identify the family to be alkene. Then they ask you to name the third one. Now, mistake can be made where you say, okay, the third one, we are looking at the one that has 3 carbon, which is propene. But in the case of alkene, that is wrong because the first one here is the one that has 2 carbons. So the second one is propene, the third one is butene. I guess you've gotten a point there. Now, coming to the first 5, the one with 2 carbon is called ethene, but also let us look at their molecular formula. How do we determine the molecular formula? So we go to the general formula. We said ethene has 2 carbons. So we just put 2 where there's N, where there's C. So you're going to have C2. And we put a 2 where there's N there, which is 2 multiply 2, which is 4. So H4. This is the molecular formula of ethene. Then let us have a look at the structure formula. Now, when you hear of the structure formula, just think of the structure showing the bonds. And you know that in this one, or in chemistry, a line is used to represent what? A bond. So we are going to draw the structure of ethene by starting by putting up carbon chain. So we connect the carbons. And you know that between a carbon and a carbon, there should be a double bond. Having 2 carbons, which means we are going to have a double bond between the 2 carbons. Then now, we connect the hydrogen around. And very important to note that carbon form 4 bonds. The fact that we have the double bond between, so each carbon here already have 2 bonds. So each one is just lacking 2 bonds to be stable. So therefore here, around we put hydrogens, and take into account how many hydrogens? 4 of them. So you cannot exceed that number. So this is the structure of ethene. So it looks like that. The second one in the series is propene, and propene we put a 3 where there's the general formula there. You know that propene number of carbon is 3. So we put a 3 there, it's going to be C3. Then H, you put a 3 where there's N, you multiply by 2, gives us 6. So in other words here, the easy way to master this is that the number of hydrogen, hydrogen is just double the number of carbon, if that is the correct way I've put it. In other words, I'm saying 3 carbons, then you just double the number. That gives the number of what? Hydrogen. Remember, these are hydrocarbons, so they contain only hydrogen and carbon. Okay, let us proceed. So now, how do we draw the structure? So the first part, we put up the carbon chain, okay? And between 2 carbon, there should be a double bond. It can be here or it can be there. Okay, so between 2 carbon, there should be a what? A double bond. The fact that we've put it in the first part, this first carbon is already bonded to 2. So in terms of hydrogen, it only needs 2 hydrogens to be stable. And of course, you put them up, down. Then this one is bonded to 1, double bond here. So which means already bonded. The mid carbon here is already bonded to 3. So it only needs 1 hydrogen. Then the last one here is bonded to 1. So this one needs 3. So this is how you assign the carbon. So never should you put more than 4 bonds on the carbon, because carbon can only form 4 bonds. So in other words, we cannot put a hydrogen here. Okay, that would be wrong. So very important to get that. All right. The next part that we look at, so we said we are going to look at the first 5, and we have just looked at the first 2. So please, the first 2, the last one, which is the second one, has carbon 3. So go on and look at the one that has carbon 4, carbon 5, and carbon 6. These are the first 5. So make sure that you answer this part is your question. All right, the other part that we can look at here are isomers of alkenes. Isomers. Where we are coming from, we looked at isomers of alkenes. And of course, we said an isomer, we're just looking at the compounds that have same molecular formula, but different what? Structural formula. In other words, they differ in their structure, but the molecular formula is the same. Now, under this one, alkenes with 4 carbon and above exhibit isomerism. Now, what I'm going to discuss in terms of isomer here, or isomers here, we are going to look at two types of isomers. One, positional isomers. Now, when you talk of positional isomers, we are just looking at naming the compound depending on the position of the double bond. And the other one, of course, the one that we are going to look at is the branched isomers. So this one, as the name suggests, looking at the branch. Okay, so whatever branch will be coming out is the one that we consider. I think this is what we looked at under alkanes. So we should have a prior knowledge to this part. So let us start with positional isomers. What about positional isomers? So positional isomers, we're saying, depending with the position of the what? The double bond. And in this case, we are saying, starting from carbon 4, going up, they exhibit isomerism. In other words, here, the example that we are going to look at is butene. Now, butene in terms of structure is drawn like this. Okay, we said between two carbons, there should be a double bond. Okay, so to start with, the double bond will be here. And let us put hydrogens around. And by the way, butene, the molecular formula is H, that is H48. Refer to the general formula, how we came up with this one. Just insert the 4 here and the 4 there, multiply by 2. All right, so butene looks like this. If I were to put the bonds around, have I put this one? Is not supposed to be there, please. And I'm just from saying that. Okay, so this is butene. Now, if you look at this butene, and again, I draw another way of putting up this one, this time around. Yeah, let me put the double bond here. Then, of course, I draw it like this. Then, of course, put this other carbon here. Let us put the hydrogens around. Let us put hydrogen around, or hydrogens around. Okay? Remember how many hydrogens are supposed to be? 8. Then, how many carbon? 4. So this one that you are seeing here, this has 4 carbons, and also this one has 4 carbons. If you are to write the molecular formula, number of carbons is what? 4. Hydrogens is what? 8. Count. Then also this one, number of carbon, 4. Hydrogens, 8. So these are two compounds that have same molecular formula, but different structural formula. And for that reason, they are called isomers. Now, our main thing here is naming these isomers. How do we name them? You know from where we are coming from. In terms of this part, okay, in terms of this part, we know that this is a branched one. So this one, we are going to come back for this. Or let me just put up another one different here, okay, since we are looking at positional isomers. So I'll redraw this, but this time around, the double bond will not be on the first one, okay. I shouldn't have gone to the branched one, but either way, we should be able to get around this one. So this is another form of this, okay. This is another form, shifting the double bond. So here the double bond is right here on the first part, then it's in the middle part, then, okay. So two of the isomers here in terms of position of the double bond. Now let us take note of this. How do you name this first one? So now, where we are coming from, we are prioritizing the branch, which means we considered the branch first by counting number of carbons, okay, going forward, backward. And we look at now the one that gives the less number on the carbon, on the double bond. So here, 1, 2, 3, 4. 1, 2, 3, 4. Now looking at this, going forward, counting going forward, the double bond will be at carbon 1. Backward, the double bond will be at carbon 3. So which one is the proper way, or the counting that we are going to go for? It's the first one, the one that gives us a lower number for the double bond. Now what do we do in terms of naming? So we know that this is butene and the prefix is but. Then we are going to put a dash. We put the position of the double bond, dash, then ine. So this one is named as but1-ine. So that is how we name positional isomers. And those that have watched the previous video to the end, I'm sure you are aware of this part. Now, let us have a look at the second one. So for a second one, let us still count 1, 2, 3, 4. Then backward, 1, 2, 3, 4. So going forward, the double bond is at carbon 2. Coming backward, the double bond is still at carbon 2. So either way, the double bond is at carbon 2. So how do we name this? We write the prefix but for the 4 carbon, then dash what is the position of the double bond? 2. This is an alkene. So 2 but2-ine. I guess this part is well explained in the previous one. So we are just going to go through quick. So let us look at the branched now. So for the branched, we have two things. 1, the double bond, and 2, the branch. So which one do we consider first? So we consider the double bond first, which is the functional group. Then whatever is going to give us the lower number in terms of the double bond, that is what also the branch will follow. So remember, where there's a branch, we said you determine the longest chain. If we are to look at going this side, the number of carbon are 3. Going down, number of carbon 2. So this means that going this side is a long chain. So it's the one that we are going to use. So 1, 2, 3. Okay? So which means whatever is outside becomes the what? The branch. So going forward, the double bond is at carbon 1. Coming, if we are to count backward, 1, 2, 3. The double bond is at carbon 2. So therefore here we go for the double bond to be at carbon 1. So that's the position of a double bond. Now to name this, after we determine that, okay, the double bond is at 1, so which means the counting, we are going to follow the forward one. This gives us the branch at carbon 2. So the branch is at carbon 2. And now in naming this, you start by putting the position of the branch. So 2 dash, what is the name of the branch? It is methyl. I guess you know why. Methyl. Then what is the alkene with 3 carbon? Is called propene. So methyl prop, okay, dash 1-ine. Let us not forget the position. So this is the name, 2-methyl prop 1-ine. Okay, so that is about isomers. This is something that we looked at in the previous video. So please, I urge you to go through that part to have the deeper understanding of this. Otherwise, we can proceed, and this time around to look at the chemical properties of alkenes. What are the chemical properties of alkenes? No, one thing about alkenes, so properties or chemical properties, so you can say chemical properties of alkenes. Okay, what I'm trying to say is that where we are coming from, we've determined that alkenes are reactive. So we can say alkenes are reactive. And the question is, what makes them reactive? So because of the functional group. So they have a functional group. Now, what is a functional group in this case? The functional group that they have is the double bond between carbon and carbon, which can break and allow attachment of other atom. And that is what we call, that is what makes them reactive. Now, what are the type of reaction that alkenes undergo? So, types of reactions under alkenes. What are the types of reactions that alkenes undergo? So one of the reaction is combustion. Okay, one of the reaction is what? Combustion. Now, combustion, where we are coming from, is us burning. Okay, so these burn to produce what? Depends with the amount of oxygen. So combustion, we can break it down into 1, complete combustion. complete combustion, and of course incomplete combustion. So the other one is the incomplete combustion, but we'll look at it at at a certain stage. So for complete combustion, what about complete combustion? So under this one, alkenes burn in excess. So these are the terms that you expect. Excess, abundance, okay? Abundance. You can talk of full supply, full supply. Then also you can say plenty. This one should be like this. So plenty supply. So any of these terms, if I use, just know that that is complete combustion. Excess oxygen or excess supply of air, full supply of air, abundant supply of air. And in this case, air, we are referring to oxygen. You know that this is the one that supports burning. All right. So they burn in excess, abundance or full supply of air. And what is produced? Carbon dioxide and water. So what is produced is carbon dioxide and water. Now, let me give here an example of the first member, which is ethene. Ethene like this. Then plus what? Oxygen, or react with oxygen or burn in oxygen to produce carbon dioxide and water. So, carbon dioxide and water is produced. Now, you need to balance this equation. That is one of the things you are going to find in the exam. Copy and, let's say, balance the equation that you are given, or write the equation and balance it. That particular part, you should be able to know it. If you are not aware of that, there's a video just right on this platform dedicated just on this part. Otherwise, you need to know these and also how to balance them. So, let us come back to this. So, combustion, complete combustion, these alkenes burn to produce carbon dioxide and water every time they burn in complete supply or in full supply of oxygen. Now, we also discussed the other type of combustion that is under alkenes, that is incomplete combustion. So incomplete combustion, simply these burn in the limited supply or short supply of oxygen, and what is produced as the product is carbon monoxide and the water. So very important to know. Questions that you expect here, you find questions such as, what are the dangers of burning these organic compounds in limited supply of air or in short supply of air? Of course, they produce carbon monoxide, which is the harmful gas when it is transported in the blood. Okay, when it is taken to the cells, it deprives oxygen to the cells, and of course, they tend to die. In the case of brain cells, it damages the brain cells. So, very important to understand that point. Aside from that, the other type of reaction that these undergo is called additional reaction. So additional reaction across the double bond. Additional reaction across the double bond. The fact that they have double bond which can break and allow room for attachment of other atoms, these can undergo additional reaction across a double bond when it breaks. Now, types of additional reaction that these undergo. Types of additional reactions. So one of the additional reaction is one, hydrogenation. Hydrogenation. As the name suggests, hydrogenation, just the addition of what? Hydrogen. So hydrogenation, just the addition of hydrogen. Okay, addition of hydrogen. Okay, so addition of hydrogen, and this occurs for hydrogenation. Before we even give the reaction, let me just give of the conditions at which hydrogenation occurs. So one, there should be a catalyst. So these conditions are very important. These are questions you find. What are the conditions for that reaction? Okay, might not come as addition, hydrogenation, but of course through the reaction we are able to tell that this is hydrogenation. Then they ask of the conditions. So under this one, the condition is one, a catalyst, which is the nickel. So nickel is used as a catalyst. Then also it occurs at a temperature. So temperature is one of the conditions of around 300 degrees Celsius. Okay, so very important to take note. Now, let me just give a reaction here for hydrogenation. So generally, alkenes generally, alkenes, when they undergo hydrogenation reaction, in this case hydrogen is added, what is produced is the alkane. So one way to convert alkenes to alkane is by hydrogenation. Remember, nickel is used as a catalyst and the temperature of this degree Celsius. I guess we are together up to this point. Now, if we look at the reaction, I'll give the simplest one in terms of structure, which is the ethene. Okay, ethene. When ethene undergo hydrogenation reaction, like we said, the double bond break. So here is hydrogen. Okay. Now this double bond break, and of course, what happened to this? It forms double bond. It forms double bond where hydrogen attach, and now you have all single bonds. You know that alkenes are single bonds. So these are hydrogens that have added, and these are the bonds that have been created after the double bond was broken down. So this is how hydrogenation do occur. So now, the other thing that is you need to understand is the importance of this process. What is the importance of this process? So this process is helpful in converting, okay? So this process or this reaction can be used in converting vegetable oil to form margarine. These are important things, okay, to form margarine. So that is the importance of hydrogenation reaction. Otherwise, we can proceed to the other type of additional reaction, in this case, which is the hydration reaction. So, hydration reaction. Now, when you hear of hydration, think of water. In this case, you are going to consider the steam, which is just in gas form. So, in other words, hydration is just the addition of water to the alkenes in the presence of a catalyst. So, addition of water to alkenes. Now, when you add water to alkenes, result into the formation of what? Alcohol. So we can say it's addition of water to alkenes to form alcohol. Okay? Now, what are the conditions? What are the conditions? So this occurs in the presence of a catalyst. So what is the catalyst in this case? Phosphoric acid. Then, aside from phosphoric acid, we have temperature. So also it occurs at a temperature of around 300 degrees Celsius. Then we have also pressure of around 60 atm. So these are the conditions at which the reaction occurs. So generally, when alkene or alkenes, when they react with steam, in the presence of the conditions listed here, result into formation of what? Result into formation of alcohol. Okay? So propene become propanol, alkene become ethene become ethanol, and so on and so forth. So I'm going to give the simplest one for the structure. So this is the simplest one, a reaction. So this is ethene, as you know from the structure. Then, of course, here you're adding water. Then what will be the resulting? Remember, the conditions are these. You can write them: 300 degrees Celsius, 60 atm. Then, of course, on top we have a catalyst, which is the phosphoric acid. Then what is going to form here is the double bond breaks, and of course leave room for attachment of two other atoms. So this double bond is going to break, and what you are going to have now is one end you are going to have OH, the other end you are going to have H. Otherwise, this is the ethanol. So this is the ethanol. So that is how one-way alcohol is made. So very important to understand this reaction. Okay. Now, what is the other thing that we can look at? So the other type of reaction that we can look at is halogenation. Okay, halogenation. So also halogens are group 7. Group 7 what? Group 7 elements. So they can add also. So halogenation, group 7 elements, they can add also to an alkene. Okay, so alkenes can undergo halogenation, where the double bond break and leave room for attachment of group 7 elements. So in other words, generally, if alkenes react with halogens forms haloalkene. Okay, haloalkene. For example, let's talk of the second member of, or the first member of the alkene family, which is ethene, this one. So when it reacts with one of group 7 elements, and by the way, I should have specified that can be bromine or choline or other group 7 elements. But for the sake of our study, let us just use bromine and choline. So let's say you have bromine here reacting with this. So bromine like that. So what will happen here is that this would break the double bond and of course leave room for attachment of the two bromine. So in this case, one bromine is going to attach there, one is going to attach there, and this is called, this is carbon number 1, this is carbon number 2. So this is called 1, 2 dibromo, 1, 2 dibromo, that is ethane, dibromo ethane. Okay, so that is what forms. If it was choline, it was going to form something like this, choline, that is hydrogen, 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 hydrogen. So this one was going to form 1, 2 dichloro what? Ethane. Okay, dichloroethane. So very important to understand these. Okay, so now the other thing that you need to know under this one is testing for alkenes. How are you able to tell that these are alkenes? So alkenes, when they react with bromine water, okay, so bromine water. Bromine water is red in color, or bromine solution in some cases. They will refer to bromine solution is red in color. So when alkenes are added to a bromine solution, it decolorize the bromine solution. Okay, so it makes it colorless. That is the identity test for what? For alkenes. So it decolorize bromine solution. Okay, so for testing for alkenes, when it is reacted with bromine water, the bromine water react with alkenes to form a colorless solution. In other words, it decolorize the bromine solution. So that is the identity test for alkenes. The question that you might find is that which one decolorize bromine solution? In the case they are listed. So what decolorize are bromine? Yeah, I mean what decolorize are alkenes. All right, so addition reaction here, or addition polymerization, one part that is remaining for this part, we are going to look at that under, that is macromolecules, under synthetic polymers. I think I'll get to explain this part there. But of course, we can end by looking at use of alkenes. So alkenes, they are used in the manufacture of plastics, they are used in making of bottles, they are used in making of raw material in the chemical industries. They are used in the synthesis of polymers such as polyethylene, PVC, and Teflon, and also used in the ripening of fruit artificially. Okay, so these are some of the uses of alkenes. Otherwise, we can end here for this lesson. So if you are interested to join us for online lessons, you can just call the number 0976 402563. For physical lessons, we are found in Kabwata, near Kabwata Primary School, just along 80th Street as you connect to Ring Road. Otherwise, see you in the next one.